All right, 3.2, we're talking about logarithmic functions, okay? Last week we talked about exponential. If you guys have a calculator, you'll notice there's a button on your calculator that says like 10 to the x. Looks like this. It's like 10 to the x. Everybody see that? And it's also on the same button is the word log. Do you guys see that? 10 to the x and log?
Yeah.
You see it? Right there. Log and 10 to the x, because 10 to the x is an exponential function and log is a logarithmic function. These are inverses of each other. That is going to be super duper important information when we get to solving. That button is going to be very important. If you guys also notice, there's a button on your calculator that says ln. All right, and on that same button is also e to the x. ln is natural log. It's from Latin. That's why it's ln and not nl. But e to the x and ln are inverses of each other. That is the only pre-calc step when you're solving equations that you have to know. Is what is the inverse? How do you undo? When you're solving an equation, if you're multiplying, to undo, you divide. If you're adding, to undo, you subtract. So when we're solving exponential and logarithmics, you have to undo. So to undo a log, it's an exponential. And to undo an exponential, it's a log. We'll talk more about that later. But understand that those two things are inverses of each other. So today we're going to talk about how logarithmic functions look. We're going to talk about their characteristics of graphing and all that stuff tomorrow. But today we're going to talk about the computational part of it. So if you guys notice here, this is what a log function looks like. First of all, when I look at this, how do I know it's a logarithmic function? It has the word log in it, okay? Very good. Exponentials, we had a variable where? In the exponent. A logarithmic function has what? The word log. So we're going to talk about changing from exponential to logarithmic and vice versa, because God bless you, like I said, they are inverses of each other. All right, everybody with me? Okay. Scooting along, here's the two different forms. Logarithmic and exponential. How do we change these? Sometimes it's easier to see when you're actually using numbers rather than letters. But what I like to think of is if you start off with a log to go to exponential, notice the little b became what? The base, right? And then what happens with the x and the y? They switch spots. And it's going to be vice versa. If you start off with exponential, then that means the big base becomes the little log base whatever, and x and y switch spots. So in this case here, this is an exponential form because it's what kind of a problem? It's an exponent. If I was going to change this to logarithmic, my big base becomes the little number. You guys see that? And then what happens with the 8 and the 3? They do what? They switch spots. So this becomes here and this becomes here. What this question is saying here, log base 2 of 8 equals 3. It's saying, how many times do I multiply this little number by itself to give me that one? That's what it's saying. So we're going to practice moving from exponential to logarithmic and simplifying them. And I'm going to show you some properties of logs that after I explain it, you're going to be like, oh, can we have a bunch of those on the test? My answer can be no. All right, write each equation in the equivalent exponential form. So let's look at A. All right, A says 4 equals, actually I'm going to rewrite it, hold on. I'm going to say log little 2x equals 4. All right, what kind of form am I starting in? Logarithmic. How do I know it's logarithmic? You see the word log, okay? So to go from log to exponential, your little number becomes the big what? The big base. And then what happens with the 4 and the x? Okay, so I'm going to have an x up here. Sorry, I'm just kidding. I'm going to have the 4 here and the x here. Everybody see that? Now, if you're going to solve this equation, what is 2 to the 4th power? X equals 16. That's it. Super basic. Let's look at B. I'm going to rewrite B. Log little 3 of 9 equals x. All right. First of all, let's move it. How do I go from logarithmic to exponential? The 3 becomes big, right? The log goes away, and then what happens with the 9 and the x? So 3 to the x power equals 9. 3 to what power equals 9? X equals 2. All right, good. You guys see that? Super basic. All right, now, how are we starting off? In what kind of form? We're starting off in exponential, and we're going to go to what? Logarithmic, okay? They're inverses of each other. So think about this. Think about this. I have b to the 4th equals 16. What is the base here? What's the big thing? B. Okay, so I'm going to write the word log, and then my big base becomes what? The little thing. And then what happens here? So 16 equals 4. So if you had to think about this, guys, think about it. What number, if I multiplied it by itself 4 times, gives me 16? What number, what b, if I multiply it by itself 4 times, gives me 16? 2. B equals 2. Our brains think exponentially. All right, so if you are ever starting off in logarithmic and you're trying to figure out what the answer is, change it to exponential, and then it's easier to solve. If I gave you this and this, you guys could easily look at that and say b to the 4th equals 16. What's b? 2. When it's in log form, it's not as easy to see. So if you start off with something in log and you're trying to solve it, just change it to exponential. So here I have x equals, or I can leave it like it is, 5 squared equals x. So think about it. If we're going to go to log, I write the word log. First of all, what's my answer? What's x equal? 25. Okay, because we think exponentially. But I write the word log, and what does my little number become? 5. And then what happens here? They switch. So what that says is 5 to what power equals 2? So if you started off here, I would change it to exponential and then solve if they're just asking you to solve. But if you're just going from one to the other, remember, if you start off in logarithmic, the little number becomes the big base, and the two things switch. If you start off in exponential, the big base becomes the little number, and then you switch. That make sense? Evaluate each function without using a calculator. Okay, well, what did I tell you guys? How do we think? We think where? How? We think exponentially. So what this says right here, this says log 4 of 64 equals what? Right, if I plugged in for x. Well, let's think about this for a second. I kind of like, wait, huh? So let's change this to exponentially. If I was going to change this to exponential, what does my big base become? What is the big base going to become if I'm going from log to exponential? 4. And then what happens with my question mark and my 64? They're going to flip. Now, could you guys answer that question? 4 to what power gives me 64? 3. We think better exponentially. So if you're given a problem and it starts off in logarithmic form, change it to exponential and then it'll be easier. So like here, we're going to find the answer here. Well, this is log 36 of 1/6 equals I don't know what. So how do I rewrite that? First of all, exponentially. What is my big base going to become? 36. And then the question mark goes here, and this becomes 1/6, correct? Ooh, look at you. Oh, well, let's think about it for a second. I like that we're thinking negatives. I like that we're thinking fractions. That's good. Think about this, guys. How could you make 36 into 6? What would you have to do? You'd have to take the square root. How do we write square roots? If it was an exponent. As a what? As a, what would the exponent look like? It'd be a fraction, right? If I had like the square root of something, this is 1/2. If I had the cube root, it's 1/3, right? So I like that we're thinking in halves, and I like that we're thinking in negatives, because if you were going from 36 to 6, the exponent would be to the 1/2 power. But why did Alex say the negative 1/2? Because I need it to be 1/6. So your answer here is negative 1/2. Very good. When you're going from a bigger number to a smaller number, think square roots, cube roots, that sort of a thing. And when you're going from a whole number with a denominator of 1 to a fraction, think negative. Very good, both of you. Very good. All right, now this is just a guide to how to use your calculator. Okay, a lot of you have different kinds of calculators. You are going to need a calculator for the test. You have to, because you guys can't do the logarithmic stuff and the exponential stuff in your head. Or by hand. You're not going to be able to do it. So this is just a nice little slide to show you how to use your calculator. We'll go through it more. But I want to show you guys something, all right? To evaluate in your calculator, if you're going to plug this in, it's -3. Then you hit the word log. And then you're going to put in 2.7. And tell me what that equals. Hit -3, then hit the word log, and then put in 2.7. You got -1.29. Okay, fine. Now, what do you guys notice about the log right here? What's the number? 10. In your calculators are programmed for log base 10. It doesn't say log 10 on it, but it does say it's 10 to the x, right? There's a 10 to the x, and if I was going to rewrite that as x as a logarithmic, this would be log base 10, right? Agreed? So if you have any other logarithm, like if you have log base 2 of 12, your calculator, you can't just put that in. Some of your calculators have the change of base formula in them, but most of them don't. I'm going to show you how to do the change of base. It's really easy. We'll do that. Well, actually, it's just log 12 divided by log 2. That's how it would. You do the visually bigger number, log of the visually bigger, divided by log of the visually smaller. That's it. But we'll talk more about that when we get to solving. Okay, properties of logs. I want everybody to pay attention to this. How do we think best? Exponentially. So if something is written as a log, make sure that you change it first. But these properties of logs will help us when we get to solving. Okay, number 1 says log base a of 1 equals 0. Well, if I change this to exponential, my little a becomes my big base, right? And then 1 and 0 change spots. So anything to the 0 power equals what? 1. If you ever have something that's log base whatever, log base 12 of 1 equals 0, what's your answer? Okay, just look at what I wrote. Log base 12, 1 equals 0. Well, it's like, wait, what? Let's rewrite that exponentially. So we would say 12 to what? The 0 power equals 1, okay? That's all that's saying. They're showing you how this works. You'll see in a second when I do this with numbers, you're going to be like, oh my gosh, that's so easy. All right, look at number 2. How's this one a little different? What do you guys notice? There's a little a and a what? A big A. So what this is saying, like just say I said log base 8 of 8. What does that equal? Well, let's think exponentially. How would I rewrite log base 8 of 8? The little 8 becomes big, correct? And then what happens with my question mark and my number 8? They switch spots? So what's your answer here? 1. Whenever you have a little number and a big number that are the same, they just cancel out. They're inverses of each other. So they'll just cancel out. And again, this is going to make a little more sense in a second here. Same thing here. Do you notice how you have a little a and a big A? Here you have a log a. What do you think happens there? It cancels out. You'll see in a second, I promise. And then what do you notice here on my equal sign? Look at the left-hand side and look at the right-hand side. They're what? Both the same base. So if you had like log 7 of 3 equals, like log 7 of x equals log 7, 15. If you have the same log on one side and the same log on the other, you can cross them out and your answer is x equals 15. These are properties of logs. They're basic properties of logs that will really, really help you when we get to 3-3 and 3-4 solving. So let's, sure. Get some of these. Whoops, sorry. All right, so here I have this problem here, and you're like, what does x equal? Well, first of all, guys, let's think exponentially. How do I rewrite this exponentially? Log goes away. What does my big base become? 3. And then what happens with 81 and x? They switch spots. So what does x equal? 3 to what power gives me 81? X equals 4, okay? All right, let's look at B. Let's think exponentially. So my big base is going to become what number? 5. What happens with 1 and x? What's x equal here? X equals 0. Anything to the 0 power equals 1. Anything to 0 power equals 1. If you have E and ln, those are inverses of each other. If I had E to ln to 7.8, what do you think happens with E and ln? They cancel. What's my answer? 7.8. All right, that's what this slide is. It's a whole bunch of these easy ones. Guys, look at 3, big base of 3, and then I have an exponent of a log 3. What happens with 3 log 3? It cancels. What's my answer? 15. Look at number 2. I have a log base 2, and then I have a big 2. So what happens with log base 2 and 2? They cancel. What's my answer? 3. Good. I have a log base 9, and then a big old 9. What happens to these? They cancel. What's my answer? Not 0. 1. When everything cancels out, what do you have left? 1. Good. And then this last one's a tad tricky. Why is this one tricky? Because it's a fraction. So let's rewrite this. We can do it a couple ways. If I rewrite it exponentially, do you guys agree this becomes log 3 of what gives me 1/3? Okay, well, how would you go from there to there? Okay, that may not be the easiest thing to see. Let's look at it this way. Could I rewrite this as log 3 of 3 to the what? -1 power? I sure could. What happens when I have log 3 of 3? They cancels. What's my answer? -1. Good. So those properties, I know that's like you're like, why don't we just do that? It's going to come in handy, I promise. It's going to come in handy because we're going to solve these. Exponentials and logarithmics are inverses of each other. Just like if you guys look on your calculator, ln and e to the x are on the same button. So if you had a problem that said like e to the ln -2, what happens with e and ln? They cancel and you're left with -2. As soon as you guys see a fraction, the easiest thing to do is to rewrite it as a whole number with a negative exponent. It'll probably be easier for you guys to see. Okay, that's it.